we'll share the slides and stuff with you.
Awesome. Thank you so much.
No problem. So there are a couple new faces in the room for me, even though I've been working with all three of the departments that do a lot of the teaching here, and the teaching is done here quite a bit. But I'm Kevin Guidry. I'm the Associate Director of Educational Assessment at the Center for Teaching Assessment of Learning. And my colleague Stacy Larkin is also a faculty developer. She supports a lot of our life science programs, so that would include the biology department. And you asked us to come and kind of help you think about kind of what can you do, maybe what should you do with a lot of the data that you've collected or could collect, would like to collect, questions that you have. And here's the original question was framed around qualitative research. And we're not really going to talk about qualitative research. I hope that nobody feels that this is a real misleading title, but I'm going to start using a lot of quotes around qualitative research because I'm not a qualitative researcher. That's fundamentally what it comes down to. And more importantly, based on my understanding of your interests and needs, I don't think you're really interested in doing what qualitative researchers would consider to be qualitative research. And we'll talk more about that as we go on in here. But so what we're doing today, just a quick loose introduction to qualitative research. Then we'll spend the rest of the time talking about what I'm going to call classical content analysis, or just content analysis for short, which you may think of as coding. Because I think that most of your needs are, we have this body of textual data. In many cases, they're responses to surveys or responses to test questions, exam questions. And you've got this text that you need to reduce typically down to a quantitative format in here. And that translation from a corpus of textual data to something that is more quantified, and here that's what content analysis is all about. So there are rigorous ways of going about that, and we're going to practice some of those this morning and talk about the considerations and how you go about doing that. So my view of qualitative research as a quantitative researcher primarily is that there are kind of two things that people talk about when they're saying qualitative research. The qualitative researchers, they're really talking about understanding the lived experience of participants. So classical examples of qualitative research are ethnographies. So this is all about what anthropologists do. So that is a signature method of their discipline. But we do this in other ways when we do focus groups or interviews, or in CTAL we do this kind of stuff when we're doing observations of teaching or of students in here. So that's really the qualitative aspect of research, and it's not about reducing things to numbers. If you ever read an article that talks about qualitative research, and there you're going to find very few numbers, very few tables that are in there, just because that's just not the paradigm that they're working with. They're working with understanding the experiences of the people that they're working with, that they're observing, that they're living with, that they're spending time with. And most of the time they're interested in forming new theory. They're not going in there with preconceived notions about this is what happens. They're going in there with pretty much a blank slate, and based on the observations, they try to understand kind of the why and the how of people's experiences. There is some of that work does go on within science education research. I mean, there's some of the learning theories, for example, that we have, and a lot of those should have and did come from qualitative research. Those of you who were around a few years ago when we were interviewing for ICE-Lab director, when John was stepping down, I don't know if you remember the two finalists that we had come in when they were doing a public presentation. A lot of what they were talking about was building on or conducting qualitative research. One of them talked a lot about extensive interviews of researchers in the field to understand how they learned how to do and how they conduct research, so that we in turn could figure out what is it we should actually be doing with students in the classroom. That was a really good example of qualitative research within your discipline, within the areas of science education. But we don't do a lot of that, and I don't think that you do much or any of that here in ICE-Lab. Maybe at some point, a few years down the line, you can get into that, but that's my understanding is you're not really doing much or any of that. You're really more interested about using these theories in the classroom and understanding kind of what students are doing or not doing, how they're understanding things, which really is just trying to collect this kind of information, but then use it in a way that really is about translating it to numbers, because that's an easy way for us to aggregate things. So that's where we get into classical content analysis. That's what content analysis is about. It's about taking a corpus of data, usually textual, but not necessarily. You can do the same kind of method with images. There are a lot of folks who do this with moving images, so video. We've definitely done this within CTAL, working with folks in IBC. A few years ago, we were using, there's a classroom observation protocol that we piloted here that is very much a content analysis kind of method, where there's a set of codes, and we applied those codes to observations we were conducting. And so we start off with this experience that we were watching, but in the end, we end up with categories and numbers and categories. And so what I'm going to try to lead you towards is the most rigorous way of doing content analysis. And then you're going to have to decide along the way how much of this rigor you need to apply and maintain given your particular need. In general, the importance of the use, what you're planning to do with it, is going to determine a lot of that, as well as your audience. So if you're doing something that's pretty low stakes and it's just for you, maybe you don't need to do all the things we're talking about today. If you're trying to do something that is going to potentially change the curriculum of a program that you're trying to publish in a peer-reviewed journal, then maybe you need to be on the other extreme of really going the full 9 yards, because what you're doing is important. It's going to be scrutinized significantly. So you need to figure out where along this continuum you need to be. So I'm going to stay on the very rigorous continuum because it's really easy to slide down in there and relax things. But if you don't ever learn the fully rigorous way, then you can't ever decide that you want to be there. So it's really easy to learn the most complicated way of doing it, and then you can kind of loosen things as you go about. So here's the typical process. So you go in here. This is a very idealized process. Realistically, you almost always start somewhere in the middle in here because you are not the one that's made all these decisions. You've got data that have been handed to you and told to analyze this in here. So this is a very idealized scenario. However, it's good to talk through. So first you talk about kind of the why you're doing it, what theories you're going to use, and then define your variables. In other words, what are the things that you're going to be looking for? What are the codes you're going to be using? I think of grading in a lot of ways as applied content analysis. Whenever you're using a rubric, you're doing content analysis of the students' responses. You're doing almost all of this in here, so you're already familiar with a lot of this. So defining variables in a grading scenario, this would be, so what are the rows in your rubric? In here, so what are the things you actually grade? What are you looking for in that response, in that survey response, in that exam in here? That you're defining variables in here, so you're already familiar with a lot of this. And then you have to operationalize these. So not just I want to see if students can write a good introduction. Well, what does good mean in there? And what do you mean by introduction? Are you only looking at the paragraph or 3 that hopefully is labeled introduction? What if they don't have a label? What if they just have everything kind of running together in there? How do you know what is the introduction? That's what we mean by unit of data collection. This in there. You got to figure out your coding scheme. That's really kind of making this a little bit more rigorous, actually writing this stuff down. Again, this kind of stuff, if it's just for you, maybe you can keep it all in your head. But if you're one of 5 people grading papers from 3 different sections, you probably really need to write this stuff down and formalize this to some degree if you think that there should be some fairness and consistency in grading. This is not done. So a census would be if you're grading papers, obviously you're going to make every student write that exam unless they decide not to in here. However, in other cases, you might just be doing a sample in there. So this is a very generalized model that we have here. We talk about reliability because frequently we would like multiple people to be coding the data. We'd like them to do it consistently. So that's what we mean by reliability. And for them to be able to do this consistently, they need to have training, they need to have a guidance, and then you need to check before you turn them loose on the data that they're actually able to apply that training and use your codebook or rubric consistently. And there are calculations that go into this that we'll actually run those in a few minutes in here. But this is the kind of stuff, if you've ever worked with TAs and kind of gotten them together and talk about this is how we grade, this is the kind of thing that you're doing. Then you actually finally go forth and do your coding, do your grading. At the end, you still want to calculate reliability, so that means that the ideal is that even though you've done all of this training, you developed this code book or rubric, you've done all this so that you can split things up and give them to different people and only have one person code each item. You want their, ideally, you still want to assign them some things in common. You know, give these 5 people the same 10 papers, even though they've got 50 other papers. Make sure there's overlap between all of them so that you can go back at the end and recalculate reliability so that you know that the process still worked. So you do it at the beginning and you do it at the end. And then you want to report both of those numbers, and hopefully the beginning one should always be acceptable, because if it's not acceptable, you should not have begun in the first place. And that means that you need to readjust your code book, adjust your training. If you've got more variables going on than you thought, something needs to change before you carry forward. So you should always have acceptable reliability at the beginning, and at the end you should, if you don't, then you've got to figure out what went wrong in here. That's a pretty disappointing, pretty bad sign if reliability goes off the tracks towards the end, because you've put all the work into this. And so don't start without good reliability, and then make damn sure that your coders are actually applying the method that you've trained them in. And then finally, you write stuff up, analyze the results, and report. So let's make this concrete. Stacy, can you hand out in here? So let's actually look at an article from biology that does this, and actually try out their rubric to code some things. So we just handed you the first 2 pages of this article. The first page, just so you have the full bibliographic information and the abstract, and then the second page has table 1, which is their rubric, or their reported version of the rubric they use. So in this case, there's some colleagues in biology who were looking at exam questions and trying to figure out where on Bloom's taxonomy these exam questions fall. Just make sure that we understand. So Bloom's taxonomy, if nobody's familiar with it, it's a way of categorizing educational goals, including you can do exam questions, you can do other things, activities, entire classes, and sometimes. But it's a hierarchy of the most simple kinds of skills of memorization, understand, recall, all the way up to much more complex skills of analyze, synthesize, create, evaluate. So there's an ordering to Bloom's taxonomy. And they wanted to figure out these exam questions, where do they fit in this taxonomy? If you think of the taxonomy as a kind of scale, kind of where along the scale do they fit? So if we look at, wow, this is totally unreadable. This is why we hand these out to you. So they list Bloom's taxonomy across the top, and they're missing one. Now they look at, they're missing one. They're missing the very high spots, because there are 7 items of Bloom's taxonomy. They don't have create. And their create should be the very top on the far right, but it's not there. But anyway, so they got Bloom's taxonomy here, and you can see what they're doing, starting to insert information, particularly in the top 2 rows, about how they can use this to be able to code exam questions. And the first thing they did was take this, really, they've got 7 different codes that could be used, 7 different, it's actually one variable, 7 different codes within that variable. But they first decide that's too many, or that's more than we need in here. So let's simplify this. So that's why they have that LOCS, that's lower order, what's the C? Cognitive skills, and then higher order. And then they've got application straddling the line between those 2, which I think is actually a pretty dangerous thing for coders, to have something that's that vague. So you'll see in a moment that I would say I would recommend they stick with 3 codes here, that they have lower order, application, and higher order. And they give you some examples. They give you some, I'm not sure, they have these key skills. I'm not sure what to call that. That's almost, it's not a definition. It's descriptive. They're synonyms. I'm not real sure exactly what to call that. And then they've got some examples below that. So these are things that should be helpful for coders in trying to figure out a particular question where it falls within these 3 codes that they've created. And they've got other stuff going on at the bottom that doesn't so much have to do with actually applying this, but kind of more the meaning and use after you've coded, kind of what does this mean. If you read the rest of the article, it's kind of a two-part process of one, they identify where these questions fall, and then they can figure out, okay, what kinds of activities can we be doing with our students? How can students practice to do well on these kinds of questions we've already identified or in the exam that's coming up? That's kind of how the rest of the article plays out. It's a really good article. I really encourage you to read it. So let's try applying these three codes that they have to some sample questions from a couple of exams. So each of these we need to figure out, are these higher order content skills, are these application, or lower order content skills? So I want you to kind of think for a moment by yourself, and then we're going to talk about kind of where you landed and why you think that. Okay, so what do we think about the first question? Higher order, application, or lower order? Yeah? Okay.
Maybe I'm not understanding something appropriately. I know that we're trying to assign a lower order, higher order, or application. But I'm really confused because application is also a column within the rubric, and that column within the rubric includes lower order and higher order.
Right. That's why I would break out application as a separate because of that very reason. In there, I would just say if it falls out, just name it application. And there, yes, I think that is a significant issue with this particular rubric. So are you saying that it's application?
Yeah, that's what I put it as.
Okay. Okay. No, is that? So we drew the, can you check to see in our notes? Sorry. Sorry about that, Stacy. Yeah, and I forgot, with Google Slides, it doesn't have that presentation view that PowerPoint would, so we've got the answers down in our notes. That's it. Because these are all pulled from the supplemental materials for this article. They've got a bunch of questions that they included in there and how they would code and a little explanation of why they would have coded them that way. So that's where we got these from. But we did have a little discussion about the application level of the rubric and how that is. So I'm going to take that, set it aside for a moment, and come back to it in here. So what do we think about the second question there? Lower order. Anybody think higher order application? Okay. So we're doing pretty good as far as iterator reliability goes. That's a form calculation, but we're not going to do it now. But so things look great. Just out of curiosity, why? What kind of tipped you off, or what made you really think that's lower order? Okay. Okay. So for the third question,
I haven't made some assumptions about this one. Because it says, based on the data shown above, we're assuming that the data that I can't see that's listed in the information,
okay.
we're assuming that as a higher order. But if it was draw a simple model based on the number from class,
Okay. So I see some nodding heads, higher order. So in my mind, draw model to me seems like very strong keywords in there. But I agree that that would be different if it were recalled, draw the model that we've already talked about, but almost any elaboration of that in there, in my mind, probably would kick it up in the higher order content scale. So this would be what I would refer kind of in the field, this would be calibration of our rubric or of our code book. This is kind of us. We're all trying it out together. We're talking through what we think, what we've observed. This would be an opportunity to make any modifications or adjustment to our code book or to our rubric. And here we've talked a little bit about, there are some keywords that we saw. That might be the kind of stuff you would include in that document to help others out. If we've identified problems, like I don't know what's going on in this application, it's labeled with all three of these things that we're looking for. That sounds like something that needs to be fixed before we move on. So this is the kind of thing that we would do until we're all relatively comfortable with where we're at and we think things are working pretty well. Because the next step here is let's talk about, because our next step is going to be for you to actually code them without us talking to one another at all in here. Should have asked you to bring your laptops. Actually, I see a couple laptops, and you've all got phones in here. We'll be fine. Yeah, you've all got phones. Because I'm going to ask you to fill out a Google form in just a moment. We're actually going to record your responses for the next set of sample questions, and then I'll use that to actually show you how to calculate inter-rater reliability. But before we do that, so inter-rater reliability, there are many different measures of inter-rater reliability. And these are all quantitative measures, so there are formulas that are used to calculate this. They all vary they usually vary between 0 and 1. Some of them actually go into the negatives. In the early, so you're looking for values between 0 and 1. Some of them will actually blow up on you in some really bad circumstances, and that tells you that you're in a bad situation. In here, but usually they're between 0 and 1, with 0 meaning that everybody selected a totally different answer, and 1 being that everybody selected all the same answers. Confusingly, 1 is often a bad place to be, because if everybody selects the exact same answer, one interpretation of that is that maybe this is not very philosophically or theoretically interesting, because clearly everybody knows exactly what's going on here. In here. So that's kind of a weird place to be. You're never going to be there in the real world with any data set of any normal size and any number of coders. But that's a weird place where you can get in some places. So like I said, there are multiple calculations that are done here. The calculation I typically use, the one I'm going to show you, is Krippendorf's alpha. And that I recommend that because of all of the calculations, it is the one that is the most general. So some of these calculations can only be used with 1 or 2 coders. Some of them can only be used with data in a particular form, so it can only be used with continuous variables or only with scalar variables. Krippendorf's alpha doesn't have any of those restrictions. And it also is one of the IR calculations that accounts for the fact that you may agree simply by chance. If there are only 3 codes that can be applied, there's a 1 out of 3 possibility that 2 different coders are going to agree solely because of chance, not because they've intentionally selected that. So there's a correction within the calculation that accounts for that. So what that means is that compared to some of the other R calculations, it's going to tend to give you lower values in here, but that's just the way Krippendorf's alpha goes. But I'm going to show you there's a website that you can use. There's an R package for anybody that's a real kind of stats nerd. There's an R package that does that. And there are other ways to calculate. I'm pretty sure there are Excel packages, scripts I'll do that. But this website that I use, I find to be by far the easiest way of going about this. And I'm going to show you how that works in just a moment. Because I would like you to go ahead and code these 3 questions and then record your responses at the Google form that I've got linked there. So does that make sense? Is everybody done? Okay, so I'm going to go in here and I'm going to talk my way through this so you can see how this is done. So first thing I'm going to do is just open up this website. So I always need to remind myself what format the data should be in. And it says that every coder gets their own column. Okay. And I do find this Google form works pretty well for collecting data like this. The only downside with it, or the biggest downside with it, is it doesn't, you would either need to put every single item that's to be coded in here, so you end up with one massive, even if you separate them, you can put them on different pages, but it ends up being this massive survey. Somebody has to take all at one time. Or you can use some survey logic to kind of break things up and kind of do one at a time and submit them one at a time. But in that case, Google Forms, there may be a way, but it'd be pretty complicated. But by default, it's not going to, if you create a dropdown that says, I need to code question 1, question 2, and there, it's not going to tell you, you've already coded question 1, question 2, in there, so it doesn't keep track of that. So we find that frequently for us, we find it actually simpler to just, once we get through this training process, actually just code within the spreadsheet itself. If you ever do that, you want to make sure that your coders are using different spreadsheets, because you don't want them for the questions or observations that overlap. You don't want them to be seeing what somebody else has already coded for that, because the coding should be done completely independently after training is completed in here. So that's kind of how some of this works. So I'm going to go into our form here. I'm going to tell Google to put your responses into a spreadsheet. I think I'll need to, yeah. So the first thing I need to do is recode these into numbers, because I'm pretty sure it's expecting, the program here is expecting numbers. And even if it isn't, it doesn't hurt. So I'm going to recode these with application being R1. Higher order being R2. I said higher order being R2. There we go. And lower order being a 0. I don't think it really matters what number you select for this program, but this is what makes sense to me. And then I think the last thing, so the program requires each coder is a different column, and right now we've got each coder has their own row, so we just need to copy this and transpose it. And that should be what it's expecting, and I need to save this as a comma-separated value sheet. And that's what gets uploaded. Okay, so but the first thing that this program asks for is what kind of variables do we have in here? So I don't know if anybody has any kind of training or experience in kind of the social, we're very much in the social science world with this in here. So any guesses on what we need to tell it, what our variables are? We've got nominal, ordinal, interval, or ratio. Okay, so they're at least nominal. Nominal means that these are things are different. They have a different name. That's kind of the baseline. Every variable is going to have codes like that. Otherwise, you wouldn't have codes for it. So every variable is at least nominal. That's just saying that these things have different labels. Here. So the question is, can we go further up in here? Because these get more fine, more granulated is one way to think about it, more specific. in here. So ordinal means that you can take these labels and put them in an order in here. So I think we can do that. I think it's implied by the language of lower order, higher order here. So I think we're fine there. Interval would mean that all of our variables, the space between all of them is the same. It's in here. So I don't think that's the case here. In here, and then ratio is another way of saying they're continuous. You know, they're numbers that can be put into a ratio with another and still make sense within our context, and that is not the case. We're not even interval. So these are definitely ordinal variables. We have to upload our comma-separated values. And before we do that, just out of curiosity, so these, what do we think it's, are we going to be happy with our inner rate reliability here? Okay. Yeah, my best guess is we're going to be really unhappy with this calculation. I'm in here. So yeah, we got one question, worked really well, and then we've got to figure out what's going on with these other two. So this is the point, well, before I do that, let's verify that is the case. Yeah, 0.547, that is not sufficiently high enough for us to continue on. We've got some benchmarks. Right here. So we're aiming for ideally above 0.8, but at least 0.67. These are kind of rules of thumb that exist for this particular calculation. So we're not quite there. Yeah? We don't know. That's why we have to discuss these things. That's why we need to go through and figure out, okay, we really need to talk through kind of, okay, who coded this question like this? Oh, so why'd you do that? And they'll talk through, and that's where we'll figure out that, oh, I did because the rubric or our code book says for us, and the rest of us will be like, oh, yeah, okay, I understand why that's confusing, or I didn't understand that, I missed it, or that's really vague in there because I read it to mean this in there. So you have to talk through, this process. So this is the calibration, still part of the calibration process of us talking through. And there's, so you talk through, make adjustments, and those adjustments could be on, apparently we've got a, yeah. So I tend to think of these things kind of, these kind of errors or disagreements or misunderstandings tend to happen in one of two places, either in kind of what I would think of things that are characteristics of the coders, and that could be either their background, their understanding, their training, their fidelity to the process, or it could be actually a problem or confusion within the code book that exists with a rubric. And I'm just very disturbed how quickly that rain just started outside. Yeah. So, we would need to talk through, if we were really going to do this, and here we would be going back to these items and saying, okay, so who coded this? Why'd you do that? We're taking notes of this process to make adjustments, and then we would pull another set of things that we go through this process again. You go through this process as many times as you need to until you get an IR calculation that works.
So we did this in this example for 3 questions.
Right.
Is there sort of a rule of thumb for how many items you would want to use the calculator?
I'm not sure. It's definitely more than 3 in there. I'm pretty sure there's going to be something about either some lower bound, some lower absolute bound, or some percentage that's in there. I haven't found anything. These kinds of rules of thumb, both of number of questions to use or these cutoffs, the people who have made these have been very unhappy about having to make these recommendations. And here, if you really go back and read some of the work by, not Krippendorf, there's another guy who had to make these, and he's literally written about how unhappy he was, but for decades, people were hounding him that you need to make these, and people asked him, he said, fine, use this, this, and this. And he's like, I've regretted saying it ever since. In there. So I think there's recommendations. I don't know how well accepted they are. Usually we're doing at least 10 with the kind of stuff we do in CTAL. That seems to be a number that gives us some confidence, gives me some level of confidence that the questions or items that were selected stand a decent chance of being representative. What you don't want is a small enough number that the ones that you selected are not representative of the larger corpus of data. So you don't want to end up that you only tested with the really easy ones that everybody agrees with, or the really hard ones, and you want there to be enough in your test sample that they fairly represent the diversity among your outcomes.
So the whole iterative process, do you want to start with a smaller number of people and then expand out, or would you want to go through the whole iterative process of refining the group?
If it were me, I would probably start with a much smaller group so that we're not, completely creating this thing with a large group. That probably would be pretty unwieldy. But maybe start with something that you've already developed some confidence with. That we've been playing with this for a week, and we're pretty confident in our ability to use this. But now we need to try it with this larger group and see if any further adjustments can be made. That would be my thinking. Right.
That's what I mean. Not stay on the fourth floor, so. I also lived in Kansas for 2 years, so we took that shit seriously. So I'm surprised the university didn't do it.
Yeah, that's what I would assume there'd be something in the building or the campus, the campus alert.
Well, the wind has stopped.
No, it says until 4:45.
I mean, that's all, yeah, we're gonna go. God. Yeah.
So let me show you a few examples of code books that we have used or are using in CTAL. The content and context are very different from what you're doing, but it might be instructive to see. Okay, so one project that we're working on right now is writing our middle state self-study. We have surveyed all of the academic programs, so a little over 300 academic programs at the university, and asked them, what are your program educational goals? What do you do to assess those goals? And what do you do as a result of those assessments? And so we had to figure out how to code those responses. And here is the first code book that we use. And you're going to see this is going to be very different from the rubric that we've been using. I find that for a project of any sort of complexity, any sort of data that have any sort of nuance to it, I find that a rubric typically has too many limitations, especially when I'm trying to use multiple coders. If the data are complex, I find that a rubric doesn't allow me to write in that cell, that one cell, or add additional rows in there. There's just literally not enough room there for me to write down all the special cases, give all the kinds of examples, the language that really makes this a clear process that is rigorous and that multiple people can apply in a consistent manner. Because that is, so when we talk about rigor in the context of content analysis, the idea is that you should develop a process such that if you were to give this process, and that's, by give this process I mean publication, if you were to adequately describe this process, meaning the background of your coders, the exact kind of content you're coding, and the training that you use, including your code book, if you were to give all that material to somebody else, they could take the same content that you use, they could take your same student exams and apply the same process, and they would come to pretty much the same conclusions that you came to. So the idea is not that they can necessarily replicate your exact numbers in there, because there's usually going to be a little bit of disagreement among coders for a lot of these things that we're doing. This is hard work, so there's going to be a little bit of disagreement, but the process should be sufficiently rigorous that that little bit of disagreement doesn't change the final kind of analysis and real-world implications of what they do. So that's kind of the goal, and I just find that typically for the work that we do in CTAL, the rubric doesn't, is not sufficient in there. So this is just looking at one code of one variable here. So we've got multiple variables, and this is just one code, and this is not even quite. So we've got some examples in here. So we've got all kinds of instructions. And here a lot of this is the when do you use this. So this particular code here is about program educational goals. So we're trying to make a judgment on which program educational goals are really good, which ones are kind of okay, which ones are terrible. So we ended up with, just like we used this morning, kind of a 3-point scale is what we ended up using. So this is just for one of those 3 points here. We'd have to scroll down to see. So this is kind of our middle scale that exists, and then we've got a third one for it to keep scrolling. And then as you can see, this is a lot more than we could fit into, or than we would want to try to fit into the cell of a rubric. Kind of, yeah. It's got well, it's got a lot of supporting explanation.
Is this like a product of the iterative process?
Yes, absolutely it is. Yes. In there. Yeah. So when we start, we typically it's a lot shorter, and then it gets built out as we go. You realize that there's this special case that we keep running into, not just this one weird one, but we keep seeing this in here. In here, it is somewhere in here, and I think we modified this. Like so, program educational goals. One special case is that we had a number of departments that submitted department level goals for them. We'd figure out, so how do we code that? What do we do with that information in there? Because there's some educational goals kind of buried in there, but there's a lot of stuff that aren't educated. They're about faculty hiring and research within the department and service in the department in there, and they're not unique to that program. Really, program education goals should be unique to that specific program, or there should be something that's unique about it. Otherwise, if you have multiple programs that have the exact same learning goals, then I'm arguing that you've probably got multiple programs. You've got kind of one program that you're just giving different names. Something's going on there. And there, so that is there's a paragraph, a few sentences about what do we do in that case. And there, so yeah, this really starts out shorter than we build as we realize that there are these different possible legitimate interpretations of what we first wrote. That we need to clarify this, or we need to account for this. Make sure that nobody does this. In here, so it comes out to be a little bit longer than what we're usually comfortable fitting into just kind of a two-dimensional table like a rubric. And we can share a few examples like this with you so that you've got at least the form of how these code books look, at least the work we've done. And we took this form from, I don't remember, some article or a book chapter about content analysis as a template. And we find that it works pretty well. Once you have it developed and tested, and here I do find it to be nerve-wracking, Stacy, when we get to the point of, okay, we're done, piloting, we've got a good code book, we think we've got a good reliability, let's go forth. And there, I find that's a really I'm really nervous at that point because you're also doing that final IR calculation at the end, so you can't slack off in the process. You can't have developed this really cool thing and then figure like, well, I'm going off by my own, I can do what I want. And then, well, no, I can't because there's this actual final check that's going on here. And ideally, your coder should not know which things they're coding are the shared items between all of them. You don't want to tell them that in there. So there's going to be a check in the process. And it makes me nervous because, often we're working with a few hundred, sets of items in here. So that's going to take a few hours at a minimum to go through. And if something's wrong with the process, if I'm not adequately applying this code book, if I'm deciding now I'm going to interpret this differently than we did in training in here, then a few hours later, next week we get back together, we're going to run this calculation, realize that's we're not there in here, that we just spent a lot of time that did not come to fruition for us. We got to do it again.
So when you talk about how efficient code is more overlap between, is there like a second person who's
Yeah.
not coding, or do they like a multiple coding?
I think it does make sense. I think that in some ideal world there would be somebody that's managing, not coding. In here, that's probably not practical in a lot of cases, that your team isn't that large. I find that once you get more than a few hundred items in there, I get lost in this, so I don't remember. Even though I'm the one who created those spreadsheets and assigned, and I use the random number generator in Excel or whatever to do all that. Most of the time, by the end, by the time I finish creating all the spreadsheets, I've totally forgotten which ones overlap. So that usually works out okay.
I was a coder, and then I just didn't care. I was like, I know who I'm coding against, but I'm not going to look at any kind of stuff and done yet until we're ready to do it.
I find that the more coders are involved, the more complex it is, the more difficult training is to get all those people to agree. In there, but you have to balance that out. About you want that bottom number of your fraction to be as large as possible, so that people are not having to spend the more coders you have involved, the less time any one person has to spend, and they're just trying to find the balance between those two. That I can work with 4 people, but I don't want to work with a full group of 10 people because that would be a zoo to do that in there. Although the ideal is that would still work for that group kind of once you set everything up and tested and got things through.
So, how many people typically
The reason why we go through all of this at the end, except for those handful of shared items, only one person needs to. That's the point of going through all this training and developing a really solid code book. We do that so that at the end we can have confidence in letting only one person and knowing that they are coding it very similar to how other people are coding other similar items. So here are a couple of examples or places to look for examples of code books. That second item right here is actually a book chapter that I scanned a few years ago. In there, so this is kind of stuff I teach some classes over in the EDD program, and this is some of the stuff I had. Literally, some of these slides are taken from last time I taught this, a little over a year ago. And then a couple of tips that are down there. So if this is something brand new for you, you might want to think about developing more codes or more variables at the beginning, because assuming everything works and you get to your end results, you've got this big jumble of numbers, you can easily, in many cases, combine codes when you figure out that, oh, we didn't really need all of that. These two things are pretty much saying the same thing, or it's trivial to combine them. And there, you can do that at the end. What you can never do is go the opposite direction and realize that, oh, I really wish we had coded this for not only this, but also for this in here. You can't just take one code at the end and split it up into two things once everybody's gone through it. So you might want to think about having more codes or more variables than you initially are thinking of, because, again, you can combine them. Typically, you can combine things at the end, and there you just can't go the other direction once things have been coded. Right.
But then it became lower versus higher.
Right.
I wonder if it was just too difficult to stay not looking comprehension. That's how we were doing it before.
Or it could be for their purposes, they realize that we don't need that level of granulation in here. That is perfectly fine for us to be able to talk about just 2 or 3 levels in here. That more than suits our purposes. The other recommendation I have is when you're developing your code books, and when you're writing it, and when you're training and applying it, focus very strongly on the manifest content and not the latent content. In other words, don't try to read between the lines. Don't try to guess what the students or what the person meant when they wrote this, said this, did this in here, but focus on what was actually observed, what was actually written, kind of what's there directly in front of you. And don't try to read meaning into it. Focus on exactly what was said. That's how we achieve reliability. That is often unsatisfying when you know the student, you know the situation, like, oh, no, I'm pretty sure they meant, and then there, well, maybe they did, but another coder that doesn't know them isn't going to make those assumptions. So to make this process a reliable one, focus on the manifest content. So that's all the formal material that we have for you. Like I said, I know that this is pretty narrowly focused on one methodology, but I find that this methodology is used in so many different circumstances because it's very general. It's about coding data that exists in some way that's usually not already quantitative, but your result, your end goal is to get it into quantitative, at least something you can count. Maybe it's not something that you can actually compare and do a lot of complex. Maybe at the end you're still having nominal kind of variables. So you're just putting names to things, but those names at least are a lot more easy to work with and understand than every one of these things being 2 pages of written material, and you've got 200 students that have all done these in here. So it's about trying to simplify data in a way that's meaningful and useful.
That process of what you thought versus what we thought just to get you from the I don't think you want to go there again. Did you see the second message that was like, oh, this means you should do this?
Yeah, so who wants to start? Who coded this as higher? The first question here is higher order. Okay, so what were you thinking? Why'd you do that?
So I was looking at the,
So did somebody else remember why they coded it? Or just make it, oh, wait, we're not, this isn't real, you can just make it real. Listen, I mean, you don't have to remember exactly what you did, but do it again in your head and explain why.
I was thinking about this as a data interpretation kind of problem.
Okay.
And then some data insight stuff, and have to explain why we did this, and interpret data in general, how it works.
Okay.
I think application engineers you know already what these are, and so now you're applying it to someone else, and so you're kind of showing that. But again, because application is higher and more it's
And? Okay.
I think I picked higher order because it's not predicting data, which tends to be emphasized in application. I guess it could be because you're predicting systems, but I feel like it's not that order of application. Because it is a new situation. I would think if it was the old order, I would just ask the question, like explain what kind of things we're talking about. But you're not given a particular situation, you can ask for the definition.
Well, I think in this case we do have a particular situation. We're already told that we've got this freakish individual who exhibits these physical characteristics. and we're told to explain why that is the case. So I do think we do have a specific example in this case. Is there anything specific in the rubric that was pulling people one way or the other? Okay. Okay. I think for me, I would be focusing on. I mean, literally, I'm looking at the comprehension column, the key skills described. It says explain in your own words, and in this situation, we have since there's provide a physiological explanation of. To me, that would be drawing me towards that if I were looking at this in here. So I might also think about maybe we need to clarify what we mean by data in here. So that would be something that we might want to write in somewhere else. Can you look at what the answer is? Right.
So you can have explanation of any of the 6 levels, but then you can never go past communication. I mean, I've done a lot of work in a lot of different papers, including this one, so I don't know, but like, yeah, it gets confusing because of that. Because you need the lower order in order to do a higher level.
Right. So that to me sounds like the kind of stuff that also needs to be somewhere in the code book or a preamble to all this. You know, say that you basically need to start with the lowest level and work your way up in here, and each of the lowest levels has to be included. For you to move on, or for you to assign a higher level, every one of the lower levels must also be included in what somebody must do to answer that question.
It does kind of imply that, at least in the first
But maybe that needs to be moved out of a footnote and be more strongly stated. Yeah, that's to me sounds like a very useful thing for us to focus on in training. And so the second question. Mm-hmm. I would think that part of the challenge with this particular set of codes is that every one of them has a label that is a word that we use in everyday discussion, but we're now being asked to use these in ways that may be different from the way we use them every day, or that our understanding may be slightly different. So maybe it might be easier to come up with different descriptors, at least for the coding process. What you really want to do is try to force people. when you're having this discussion, you should be encouraging people, go back, what about the rubric? What about the thing you looked at? And comparing that to the code book or the rubric, kind of how did you discover a relationship between those two things in here? So that's very much focused on the document that everybody has in common, not just on their own experience or things locked up in their own head or their own interpretation, and here to drive people back to. I thought that because the rubric says, or it's got this keyword that matches, between them, or as you have discussion, you realize that, oh, we need to add that keyword or that kind of example in here that would really clarify things for a lot of people. If I remember the third one, that was the one that everybody agreed on. Yeah, define what it is. Yeah, that's pretty clearly lower order. Yeah, but even that to me seems like it's still regurgitation of what the text or the lecture said.
And that might be why they use the lower order, and then you have to say, knowledge plus comprehension.
Right.
Right.
Right. Yeah, that's a really common trick to kind of bring something up to a higher level, is to give it a context or give it an actual audience. And they have to bring in nuance. It's not just repeating what was there, but what's going to be meaningful in this particular situation for these particular people. So is there anything else that we can help you with, either this process or more general thoughts on the kinds of questions that you're looking at, the kinds of data that you have? Yeah, so one thing you might want to think about is what are going to be the units of analysis in that? Are you looking at putting codes to the entire 8 minutes? Or are there discrete sections of that? So you've got multiple questions and they're usually like a minimap, but you can create kind of divisions within that spoken dialogue or within that video, or maybe not. And we find that even though a lot of times we expect there to be a natural kind of breaking point, we find that in the real world that a lot of times it's not there. So we end up, bless you, having to code the entire thing, which is very unwieldy and leads to some complications in there, because when you've got 2, 3, 4 pages or several minutes of video or a lot of audio in there, it's easy to miss something that's critically important. And that happens a lot in our kind of the training that we've gone through and creating code books in there, that somebody will say, well, I coded because they said this. Shit, I didn't see that they said that. I would have changed everything if I'd seen that one word in there, but I didn't, because there are 300 other words on either side of it.
When you do audio, like I imagine if you're grading a paper, you do those a couple of times. So for audio or video, how many times do you recommend? With me, for the you just go back to the audio.
Right. So the general thinking is, to, no matter what you're doing, to go through the whole thing at least once. They call that kind of a holistic read. So do at least one holistic read of the whole thing, then dive in with the details. And I think that's going to depend a lot on the situation and circumstance. Sometimes it's really clear exactly what it is. Sometimes you got to reread it 5 or 6 times or listen to it several times, or a particular section of it multiple times. Go back and forth a lot of times. And then I say listen to or read or watch the whole thing at least once all the way through, then go back and apply the code.
They said it incorrectly, but they said something that would put that kind of order. So we had to make a decision that we just listened, that they said something about that. And they had a discussion, even though it wasn't the correct discussion, they had a discussion. The topic was touch. And so even though we didn't like it, the answer, we had to kind of come up with their having that conversation about that. So that's things that we'll start to talk about. Where do you want, is it more the correctness or that we're taking these topics, we know they're not, but we would expect them to study in that topic. So that's
The contest is very different than interview or structured because they're student projects.
I had to watch the clip and talk about their experimental design and their data. They were like 30 minutes, an hour and a half video. I had to watch those. And then there's like the thing. So like the first time I did it, I was like, well, they didn't talk about that correctly, so I'm not going to code it. And then I got back. No, we're looking at this. Do they talk about it? Oh, okay. Now I get that. Okay, now I'm going to go back and code everything.
Yeah, so just like you found whenever you try to apply rubrics to student answers, that any rubric or any code book is usually going to be very, very sensitive to how the data were collected. In other words, you could want to gauge students' understanding of their ability to do this thing, but if they're not clearly asked to do that thing in here, then you're going to have a tough time seeing that in some cases. Not because a student is unable to do that thing, but just because they were never asked to. You never explicitly said that you must demonstrate, whatever, and even though that's kind of what you want them to do. And there's, so you end up in the situation. What do I do? They did something kind of leaned in that direction, or they said they could do it, but they didn't actually do it. And then what do you do about that? So yeah, you'll find that sometimes there's just frustration with, why did we, write the exam like that, or how could we have ask them to do this, but not this in their poster presentations. And there's usually intimate sensitivity to how the data were created and collected.
So say we find a paper, they have this theory we're looking for, we kind of enhance our study. They've already done a rubric that we can kind of take and test. How would you go about using their research? Because I know it's always in education, this idea that it doesn't always match everything you're doing.
Right.
How would you do it?
So I think the first thing is, even if you think it does completely match, you are still obligated to test it and make sure that it works. That's one of my pet peeves. People say that, oh, we've got this instrument that's been validated and we know it's reliable. And I'm like, no, those validity and reliability always depend on a particular context. They were valid and reliable in that specific context that those people use, and I don't know if it is for you. So you need to make some sort of argument, either testing it or at least try to make an argument that, oh no, the situations are really similar. They use it in R1 university. We're at an R1 university. Their students look like this. Our students look alike like that. So you can make some arguments, but it still comes down to validity and particularly reliability. That's a quantitative measure in there. So you really should be actually trying that to make sure it holds true. But then I think you frequently do have to make modifications. But again, it also depends on the situation, the purpose that you're using it for. If your purpose is to use those original results as a benchmark for yours, and maybe you shouldn't be modifying, or maybe instead of modifying their rubric, maybe you need to add a few variables of your own so that you can still make the comparison you want to make, but you've got this additional set of variables that capture the uniqueness of your situation or these additional questions you had that the original researchers didn't have.
won't match, but it'll be ideal. I would like to add that to them for doing something like coursework or activity for it. The application for it. But no. We were thinking of starting in 4 courses and then going bigger. But my biggest time to write is summer. So if my work start writing over the summer, it's not going to happen until another month.
The fun thing about coding is that once you get to where we're all the paper is on your phone. So you can say, oh, I have 20 minutes today, I'm going to do a couple, and then come back to it and do that. So
It would also give us a chance if we start coding it and some instructions we don't like, we could change the assignment instructions for spring. So if even if it's just giving them some general information or tweaking it, a general direction, it doesn't impact the actual reading of it. So, but if we don't get the reading of the spring, then it's I think that if you want to really benefit from it, then
One thing that I forgot about that we did figure out about a year ago, we started doing this, whenever we're doing our training and our preliminary work.
I submitted this on this.
Yeah. So we found it really helpful to add some open text questions within within this form as we're doing our pilot training, to ask why did you apply that code in there. That makes the discussions afterwards a lot easier. So instead of people having to go back and kind of refresh their memory, why did I actually get them to write it down as they're doing it? And here, that makes it a lot easier to have the discussions afterward. And you could also be looking through this in here and figure out, 3 of the 4 coders said this in here. We need to add that to the code book in here. So that's something we figured out at some point to start doing. That's actually made the process a lot easier.
You have to give us an example.
Right.
When we write the paper, I was like, I got to go through other papers and find that example again. So then we already had it. We could say, so this was their example.
Right. So that's something, if this were real qualitative work, they would be doing that, because real qualitative work usually involves in the old days, it would be literal highlighting, printing out of transcripts, and highlighting and post-it notes to be highlighting phrases that they're associating with particular codes that they're developing. Nowadays, it's all done computerized, but it's like the computerized version of that. It's like you're literally highlighting, you're using whatever the tool is in Vivo or whatever, that the software virtually does that. So it's really easy to look back at the codes, and you click on the code and it'll pull up every single example, because to apply that code you had to have highlighted a particular phrase or a set of words or drawn a circle around or whatever. And so yeah, that's something we do have more. Those of us who are really not qualitative researchers who are doing more of the quantitative work have to kind of reinvent that a little bit.
my light. So, wait, last before.
So I'm happy to help with that. You can contact them.
Yeah, I would encourage you as much as possible. And so ideally, your program goals overlap significantly or completely with the course goals. that you have. So I would encourage you to the extent possible, see if you cannot collect data that somebody grades and then go back and code for a separate thing. If there's any way to do that all at one time in here, and so if your goals completely overlap, then that makes it possible in there. So as much as possible, think about not looking at the same stuff twice. If you have, someone's going to have to look at it, let's see if you can get the grading scheme to be as rigorous as you need it to be for the research questions you have. And that's not always possible, but where it's possible.
And I've done it both ways. I've had to go back and redo all the, we gave them a grade, but then we were really looking for certain topics that they would compare and contrast.
It's hard to have these where it's not reliable, fairly reliable enough for class. We have one. You have to thank Kevin. I just want to find out he is really find out how much time he needs, what is his requirements, because it was for something, right? Okay. So I just want to make sure we're not losing what he needs.
Right, let us know how we can help.